Michael, I'm a software developer. Oh, thank you. I work 3 blocks that way out of my house, and recently I wanted to make a DApp. I kind of had an idea for a tic-tac-toe game. So the idea is that you can create a game, engage with opponents, play it. It keeps state on the blockchain. All of your moves are done through transactions. I should probably back up a bit and explain that this is Ethereum and using smart contracts. So if you want to do something like that, there is a framework for developing dApps. It's called Truffle. Has anybody here already played with Truffle? Cool. All right. So for the rest of you guys, hopefully this will be interesting. It's kind of like app development on steroids. If you guys know like Rails, it's kind of like an out-of-the-box solution. So the very first step of Truffle is it is installed as an NPM package. So it's you use NPM, install it, it's there locally. If you guys don't have any experience with NPM, you install that too. When you create a Truffle project, it will create files for you. So it'll create your entire directory structure. It'll create contracts, migrations, it'll create a test directory, and then a build folder. So I'll just go over what those things are. Actually, I'll get to them in a second. The other piece that you want is a local copy of the Ethereum blockchain, not the main one, but one that you can develop against. So you have a couple options. The first option is something called TestRPC. And so when you run that, it runs a local blockchain. It gives you some accounts to start off with, play around with. I think it puts money in them, Ethereum, and some private keys for the account. So if you use something like MetaMask or something, you can put it in MetaMask and interact with your dApp through the browser. You also have the option of another solution that Truffle puts out called Ganache. I don't actually know what Ganache is. I think it's a food pun. They sort of, like they're puns. But it's just basically the exact same thing. You can see there's a bunch of accounts with balances. For the sake of this demonstration, I'm going to go with TestRPC. The next step, I can't really help you with. Solidity is kind of a fickle language, so you want to write some code in that. In this case, I'm going through a really simple one. Creating a contract, it has a function, and it has internal data store called a mapping. And a mapping is just going to take every possible address, and that's like a hash or a dictionary, a hash map, something. That's the key. And then the value is some sort of data type. So in this case, it's unsigned int. And we're going to call that number of games and make it public. I don't want to get too much into Solidity, but making it public means there's a getter method for it. I think it also probably creates a setter method. But in this case, we're creating a setter. No setter? Just getter? No setter. All right. So then we're creating another public function called createGame. And when you call this, you're not going to give it any parameters. Instead, it's just going to infer who's calling it. And that's derived from message.sender. If you guys have played around with Solidity, that's something that just comes baked into the language. So we're going to say when this function gets called, we are going to increase the value of the number of games. So if I call it, I start off with 0 games. I call it, and now I have 1 game. I call it again, I have 2 games. Pretty straightforward. Once I've built that contract, I'm going to run compile. And if I don't have any syntax errors, it's going to produce something that sort of looks like this. If I do have syntax errors, I'm going to hear about it. And I think it uses Sol-C, the Solidity compiler, under the hood. It will also produce a ABI. That is the application binary interface. So that tells you if you're like a JavaScript consumer of this contract, what parameters you have to send to a function, what values you can expect to return, what functions are available, that kind of thing. So you need that in order to interact with any sort of contract that's been deployed onto the blockchain. The next thing that I want to do, so I have this built contract, I want to put it on the blockchain. In my case, I'm going to put it on my TestRPC network. I need to configure Truffle. Truffle gives you a JavaScript config file. Pretty simple, telling it local host port 8545. Once I do that, now I can migrate the build artifact, the contract, to the blockchain. So I run Truffle migrate, and it will create a transaction. And so this will send the compiled contract and the payload of the transaction to the blockchain, and in return, I get an address of the contract. It goes pretty quick. Just know that right now we're going to grab the address of the contract and use it later. Like all good projects, you should probably test it. I don't know if you actually do, but you should. In this case, it uses Mocha. So if you guys are using JavaScript, it's a pretty common framework. It looks a lot like RSpec for Ruby. All I know is JavaScript and RSpec, so that's as far as my analogies go. Instead of a overall sort of describe, it gives you a contract, and then each individual assertion is wrapped in an it function. So in this case, you're saying, hey, everybody starts with 0 games. This contract gives you a list of accounts. If you guys have played around with Web3, which is the JavaScript library for interacting with dApps in a browser, it's using Web3 here. So Web3 will give you the ability to, deploy a contract, use it once it, has successfully been deployed. Keep in mind that because this is the test, it's going to do its own deployments to the blockchain. It's not going to use an already deployed contract because, you don't want to be modifying the state of, your production code. So all we're doing here is we're saying, hey, when this contract is deployed, get a copy of it as instance. We're going to call it with the first account. And when that's done, it's going to use a promise. You can't call these things synchronously. It's going to return the value, and we're just going to make an assertion that that number that comes back is 0. And we're going to say the user starts with 0 games. So that's pretty much it. Once we run it, Truffle test, moment of truth. I know in this case that it will probably pass. It passes, which is good. And then you can add more tests or move on, something like that. If you practice TDD, you can add a second test. So here I've sort of code folded up the first one. The second one now says, all right, well, great. I start with 0 games, but now when I call create game, I should go up to 1, right? So in this case, we have 2 thens. We start from this blank state, and then we create a game, and then we call number of games, and then we assert that that value is now equal to 1. And that passes as well, thankfully. Probably should have written the test first. But what Truffle also allows you to do, and this is my favorite part, is it allows you to interact with your deployed contract on the blockchain through a console. Oh. So yeah, it's pretty cool. It's a REPL. What you can do is if you take the address of the deployed contract, you can then say tic-tac-toe, which is the contract name, at this address, and now you can start interacting with it. You can say create game, you can say number of games. And so in this case, I'm using that public number of games getter method, and it returns 0 in the beginning. I say create game, the transaction is successful, and now I say do it again, it returns 1. I create another game, and I do it again, and I'm up to 2. So you can sort of see if you're more of a visual learner, you can interact with it that way. It's pretty cool. Other things you can do from within the console is you can just retest. You don't have to exit the console. You can compile, you can migrate, stuff like that. Yeah, so I didn't really get into what it looks like once this app is deployed on the blockchain. Truffle is good for building it, deploying it. Because it's an NPM package, you can just run NPM in that directory. And if you have assets, like if you have your JavaScript file that is responsible for your single page app or whatever JavaScript you want, it'll serve that up, CSS, HTML, stuff like that. If you want to integrate it with another application framework, I think then you need to do a little bit more legwork. But yeah, you can just change the config file to deploy it to the mainnet if you want. You can box up your project and publish it so anybody else can pull it down, or you can pull down somebody else's box, kind of like Docker. And then it also comes with, and I haven't played around with this yet, integration with Redux, if you guys have used that to do state management of the DOM. So like when you get a transaction result coming back, then you'll know, okay, update this part of the DOM, put a little bit more sanity to your JavaScript. That's all I got.